Okay, we're going to import the depth elevation model data. So, usual setup. Get all of our packages loaded. Tidyverse, SF, and raster. We really need raster this time. And because it's a raster data set, we have to read it in with raster. So I'll say DEM is raster. And there's the data set name. And I'll look at its coordinate reference system. And this is a little bit of a problem. Its datum is NAD83. So it's not WGS84 as everything else is. So we're going to have to do something about that. And then, okay, I recognize the geography. There's the Golden Gate. Here's the Bay. Here's Treasure Island. Here's Marin County. And there's San Francisco. Okay, everything looks normal. Fixing the CRS. We can't just give in a raster, to change the CRS on a raster, you can't just give an EPSG number. You need to actually grab a CRS from something else, and that's what we'll do. We'll bring in the shoreline data, and then we use that. We use the CRS from the shoreline data to convert the DEM, I'll call it DEM transform, is project raster. DEM CRS is CRS of shoreline. Okay, so that worked. After that, if you look at it, it actually now has a CRS of WGS 84 or 4326. Okay. Now, in order to plot it, ggplot2 cannot plot a raster directly. It has to be converted to a data frame. So this thing works as.data.frame, and then we glimpse it, and we see that we've got the x-coordinate and the y-coordinate. And you can see that these are longitudes and latitudes, and the actual data is a column called DEM underscore SF. That's from the original raster data. Okay. So we get the data frame, feed it into ggplot, and then gm underscore raster, not gm underscore SF. And we make sure that in the AES we specify that x is the variable called x and y is the variable called y. And even though they had those names, you have to specify that in the AES. And then fill is dem underscore SF. And there we are. As you can see, there's the Golden Gate, the Bay, Marin County, and San Francisco. Okay.